All right, so the last couple of lessons, sorry for the people who have been away, you have missed a lot, but you should still be able to follow along with what we're doing today, even without having done some of the work yet. Today we're looking at regions, which is graphing inequalities on our number plane, or our coordinate plane. So the graph of an inequality represents a region on the Cartesian plane. For example, if I want to graph y is greater than x plus 1, we start by just drawing the line of y equals x plus 1. However, we do need to consider that sometimes we need to use a dotted line and sometimes we need to use a solid line. If there is an equal to sign on your inequality, you draw a solid line. If there's no equal to sign like this one, we would draw a dotted line. Okay? Then once you have drawn your line, then we need to test a point to determine which side of the line or curve to shade. Okay, so you probably remember doing that in year 10. The first couple of questions are going to be pretty much very similar to what we did in year 10, but it will go into some of the harder types of graphs towards the end. All right, so let's get started. Number 1, if I want to sketch y is greater than x squared. So first of all, we just ignore the inequality part for a second, and I'm going to sketch y is equal to x squared. That is our most basic parabola. We're going to do all the graphs over on the right-hand side. So the basic parabola has vertex at the origin, 0, 0. And we could also put a point on either side of that to show the steepness. So if I went to x is equal to 1, 1 squared is 1, and I would have another point there. If I went to negative 1, that squared would also be a positive 1. Remember that symmetry of parabolas makes it very easy. If you know one side, it's the same on the other side. Because, before I draw the line, because this had an equal to sign on it, it will be a solid line. So a solid line parabola coming up through those points. Maybe I'll write that down for you, a little reminder. So greater than or a less than means we're going to use a solid line, or equal to, sorry, but without the equal to sign, it will be dotted. Okay, some of these inequalities are intuitive, and you may already know which side of the line to shade, but often marks are allocated for the testing part, so I still encourage you to please write it down. So I'm going to test a point, and you can test any point that you like as long as it is not on your graph. So often we like the origin, but that's not going to work for this one because I'm on the origin here. So I might just choose a point straight here, so 0, 1. So I'm going to test 0, 1, and that means I sub x is 0 and y is 1 into my original inequality. So y is 1 greater than or equal to 0 squared, which is just 0. And I need to know whether that is true or false. Is 1 greater than or equal to 0? That is true. Okay, so because my result was true, that means that this point that I have chosen is the correct side of that line to shade. So I'm going to shade all up in the middle of that parabola. Okay, so is that familiar from year 10? Yeah, good. First question done. Let's go on to question 2. Does anyone need more time on that screen before I move it? No, we're good? All right, question 2. This time we want to sketch x squared plus y squared is greater than 16. So just like last time, we're going to sketch it as if it's just a normal x squared plus y squared is equal to 16. And hopefully you know what type of graph that is. What is it? A circle. Excellent. What's the radius of the circle? 4. And I probably should have asked this already. Where's the center? The origin. Okay, so it's a very basic circle with a radius of 4. So over on the right, let's draw that. Remember that these don't necessarily have to have every single marking measured on there, but you just need to show intercepts where possible and for things like the parabola, the steepness. So I'm just going to have 4s the whole way around. Before I draw the curve, This was a greater than sign, which means I need a dotted line. Sometimes if you forget, this is why you should draw graphs in pencil. You can just go through and use your rubber to just make little dashes going through it. Okay, so your dotted line in a circle. Try and make it look like a circle, not a weird square. Okay, once we have our line or curve on there, we need to test a point. This time, the easy point to pick is the origin. So I'm going to test 0, 0. So into the original equation, I would have 0 squared plus 0 squared is greater than 16.
Yes.
No. 0 squared is just 0. Is 0 greater than 16? No, it is not. Okay, it is smaller than 16, which means that the origin was the wrong side to shade. We're going to shade all the way around the outside. So you're going to have little shadings coming all out here. It's a bit like a sun, yeah. Yeah, it is like that. Okay, question 3. They're going to start getting a little bit more different from here on. Question 3, I want to sketch y is greater than 1 over x. So again, without the inequality first, if it's y is equal to 1 over x, what type of graph is that? A hyperbola, excellent. Where are the asymptotes?
0.
X equals 0. And y equals 0. 0 for both. Okay, zeros. Okay, so let's draw that. So a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. And hopefully you also know what the hyperbola will look like, those two little curved shapes on the sides, but we should show a point to show the steepness. So if I sub 1 in, 1 over 1 is just 1. So when x is 1, y is also 1, and that gives me at least 1 point.
That's what I meant, yes.
That's what you meant, okay. To get that part of the hyperbola. Similarly, if I subbed in that x was equal to minus 1, 1 over minus 1 would be negative 1. So it would be down here. Oh, I have made a fatal flaw. I forgot to check my dotted line. It should have been dotted. Sorry, guys. Dot that line. This is why erasable pens or pencils, dotted lines.
Dotted line makes it look like a asymptote.
It does a bit. Different colours help. Yes, that is a good one to do as well, Ben, I heard that. If you do forget, it has happened many times before, I have people go, all right, I forgot, but this is meant to be a dotted line. If you write a note that you do know you've done the wrong thing, do something like that, and you will still be fine. Okay?
Yeah.
Okay, so we've got our hyperbola on there. Now we need to test a point. So what I might do, the origin is not a good point because it's on my asymptote, which means I have a 0 on the denominator. So even though it's not actually on one of my curved parts, I can't sub in an asymptote either, okay? Yeah. So let's start over here. I might pick a point over here, 2, 2. Great idea. So let's test 2, 2. If I sub that into the original equation, it is 2 is greater than 1 over 2. Is that true or false?
True.
2, that is true. Okay, so there would be a shaded section over here. But be careful with hyperbolas. Is that the only shaded section? It is not the only shaded section. Let's try another one. Let's test 2 and negative 2. No? Oh, I'm going to do that. I'm going to do a few tests just to show you. There's a couple of different sections here. There's this section in here. There's in the middle to the asymptote, down here, and also on this side of that side. So there's potentially 4 different parts that you could test in here. Okay? So let's test 2, negative 2. So y is negative 2. is greater than a half. Is that true or false? False, okay, so there's not going to be anything in there. Let's try the next section. Let's try -2, -2. So that's going to be on this side down here. Okay. If I put that in, I will get -2 is greater than -1/2. Is that true or false? False. Still false, so that doesn't work either. But the one spot left to test would be at -2, +2. So -2 here, +2, so up in this section. If we sub that in, I get 2 for the y is greater than -1/2. True or false? True. So that actually means above that bottom curve here, up this side, anywhere up this side of that and up to the vertical asymptote will actually be a possible solution. So that you be careful. There's actually 4 different sections that you need to test around there to know for that inequality. Or, thinking about it, if you say y is greater than both sides of your hyperbola curves. Yeah, so if it said less than, where do you think it's going to be? Here and here. Okay, all right. Question 4. Let's sketch y minus x in brackets all squared is greater than 0. So first of all, without the inequality, we want to sketch y minus x squared is equal to 0. That is not, in that form, is not a graph that we're used to seeing, but I could square root, because there's no inequality there anymore, I can square root to get rid of the squared there, which would become y minus x. When I square root 0, I don't even have to worry about the plus or minus, it's just 0. And that means this is really just the line y is equal to x. Okay, it's the inequality part that will be interesting for this one. So to draw it, okay, I'm going to say it now before we draw it, dotted line, because there is no equal to sign on that. A dotted line, yes, say it again and again so we don't forget. So y is equal to x is a straight line that goes through the origin. And if x is 1, y is 1. If x is 2, y is 2. They're always the same value. So it's going to be a dotted line going... You forgot already.
Yeah, it's dotted.
Dotted line going 45 degrees through your axes there. Okay, so we've got the line part, but what effect does that squared and that inequality part have in terms of shading? So let's test both sides, because this is a bit of a special case, this one, to see what happens. If I test, okay, can't test the origin, so let's test 0, 1. Okay, so I'll pick this point up here to start with. 0, 1 into the original inequality, okay? So that is that 1 minus 0 squared is greater than 0. 1 minus 0 squared is 1 squared, which is 1. Is 1 greater than 0? True or false?
True.
True. So that is the correct side of the line to shade. But that's not the only side of the line to shade, as you will see. Let's test something on the other side of that line. If I test, let's kind of reverse that. Let's go to 0, -1. So I'm just popping down here below the line. And if I put that into my equation, I have -1 minus 0 squared is greater than 0. That's -1 squared, which becomes a +1 again. And +1 is still greater than 0, so that is true as well. And although it checks out with the maths, it should also check out logically as well. If you think about this here, anything that you subtract or get in there, as soon as you square it, it is always going to be positive. Okay, this is always going to be positive. The only part that is not a solution is when it's actually equal to 0. So the dotted line, all of these dotted lines, anything on the line is actually not a solution, but everything else is. Okay? All right, let's keep going. It's interesting though, isn't it? I know, because you love graphing. All right, question 5. Sketch the intersection of, now we're going to have two graphs. We have y is greater than x squared and x plus y is less than or equal to 2. So we have two of them together. Yeah, you're saying the pound symbol. It doesn't, my computer doesn't like transferring less than or equal to signs into OneNote. It will do a less than or a greater than, but as soon as it puts the equal to sign on there, it likes to change them. Okay, so there you go, should be that. Okay, so just do them one at a time to start with. The first graph is, let me change pen color. It is y equals x squared. Just ignore the inequality part. We've already drawn this. That's the basic parabola.
Dotted line as well.
And a dotted line, thank you. Okay, so basic parabola goes through the origin. It goes through 1, 1, and also negative 1, 1. And we want a dotted line for our parabola. Okay, equation 2 is x plus y is equal to 2. Then that is going to be a straight line. Yes, you could even change that around if you'd like to have y is equal to minus x plus 2, if that helps you see in the gradient intercept form. My y intercept would be at 2. And you could do a gradient of negative 1, but I would probably prefer to see your x-intercept, which would also be 2. And to get that, in case you're wondering, you're subbing in when y is equal to 0. If y was equal to 0, you'd get x equals 2. Okay, so this one is, the inequality had the equal to sign on it, so this will be a solid line going through those 2 points. I'm going to rule it. Oh, maybe I can't. Oh no, it will fit. Okay, it should be going through the 2. Okay, I need to test points on that for both of those inequalities. So I'm going to do that just above here because I still need some space below. You'll see why in a minute. If I test for this first one, I need a safe point to test. What do you think?
0, 1.
0, 1. Good idea. All right, so let's test 0, 1. If I put that into that inequality, I get 1 is greater than 0 squared, which is just 0. True or false? True. Good. All right, so it's going to be, I'm not going to put that on there yet. That's going to be, this is the correct side of the parabola to shade. Let's test the line though before we do any shading. So let's test, for the line, I can test the origin because that's not on the line. And that would be 0 plus 0, which is 0, is less than or equal to 2. Is that true or false? Also true. Good. So that means parabola I'm shading up, the line's going down, so it is this section going in between them. So just shade that one section in between. There is one more thing to consider, which is the points of intersection of those 2 graphs. Often you'll be asked to find them. So algebraically, you would do some simultaneous equations. Let's do that in this little space we have left on the left. If this is equation 1 and this is equation 2, I'm going to sub equation 1 into equation 2. That would give x plus, instead of y is equal to x squared is equal to 2. That's a quadratic. Let's put it in the right order. X squared first, plus the x, and then subtract the 2 from the other side, move it all over so it's all together. Then we're looking for two numbers that times to give -2 and add to give a 1. Correct. So it'd be x plus 2 and x minus 1. And from using null factor, we can get our solutions for x, which is that x is equal to a -2 from that first one, or x is equal to a 1. And you would sub back into either equation to get the y values. So let's just sub into the first equation. If x is -2, -2 squared means that y is going to be 4. Or putting 1 in there, 1 squared is still 1. So the points are -2, 4, and 1, 1. And you could label those on here. So 1, 1 is that point of intersection. So my line should have been nicely going through that. Hopefully yours has got a nice scale there. And this other point over here is at -2, 4. Although, wait a sec, don't do those dotted. I should, draw that a line again. I should have drawn solid lines. There was one more thing I had to talk about. Because I have the dotted line where I cannot have any solutions on that line. The points of intersection, do you think those are actual solutions or not? They're not. So because of that, we actually need to, once we've found those points of intersection, we're going to put open circles here and here to indicate that they are not solutions because of the greater than sign that was on that parabola. If they both had equal to signs on them, then we'd use coloured in dots. If they were both just greater than or less than signs, they would still be open circles. Okay? All right. Now, what you're going to find, there's a couple of questions in your textbook that are going to talk about finding the union. Okay, so see here, sketch the union of. And we're kind of talking about those probability words again, where union means or, and intersection. So the one that I just did before said the intersection means and. So the one that I just did meant it had to satisfy both criteria, and that was the section that I shaded. But if it says or the union, it could be either part. As long as it satisfies one of them, then it is the solution to those equations, all right? So you could write that down as a little reminder on the side if you like over here. So if it says union, it means or, just like in probability, and that's our U-shaped symbol. If it says intersection, it means the word and, it has to have both of them. Okay, and we used those symbols a bit in our first lesson as well for those of you who were away. Okay, so let's sketch the union of xy is greater than x squared and x plus y is less than 2. So it's the same, they're the same two equations as what we had before, right? But how is it different when I use the word union? Let's just draw them quickly again. So my parabola goes through there, it goes through 1, 1, and -1, 1, and it was a greater than, so a dotted line. And the other one was a straight line going through y is equal to 2 and x is equal to 2. And it should also go through 1, 1 because we found that in the last question. And it's a solid line. So if it says y is greater than x squared, it can be anything up here, all of this part all the way up here. Never mind that it's going past the line, all of that part up there. But if it says less than the line, the 2, it's going to be all of this part down here, including the overlapping section, like that. The only parts that it is not is this tiny little part that will be growing out here and this part out the side. Okay, does that make sense? Because it could be or. It doesn't have to satisfy both equations, it just has to satisfy one. So all of this part in the middle of the parabola, that satisfies the parabola equation. All of this part down below here satisfies the straight line. Okay? What does that mean? Because last time I drew those open circles on my points of intersection. What does it mean for these now? Yes, because as long as it satisfies one of them and it's going to satisfy the straight line, it will be a solution. So those would now be coloured in dots at those points of intersection. Okay, so look out for those key words, okay? So intersection and union. All right, we're on our last page. Question 7. Sketch the region of the absolute value of 3x plus 2y is less than or equal to 6. We know, hopefully, that because of those absolute values, we actually have two equations that could come out of that. We have that 3x plus 2y could be just, ignore the inequality sign part, I'm just doing the equals to, could be equal to a positive 6, or, actually I'm going to write that further to the left so I have more room. 3x plus 2y could be equal to a positive 6, or the 3x plus 2y could be equal to a negative 6. They are two separate lines. For each of them, I need to sketch both of them, so let's find their intercepts. So for the first one, when x is equal to 0, if I subbed x is equal to 0 into that equation, I would just get, 2y equals 6, and dividing by 2, I would get y is equal to 3. If I were to sub in when y is equal to 0, I'm finding my x and y intercepts, I would get 3x equals 6, and dividing by 3, I get x is equal to 2. Okay, let's put those on our Cartesian plane and then come back for the second one. So my first line is going to have an x-intercept of 2, so 1, 2, and a y-intercept of 3. 1, 2, 3. And it's a line, so okay, think about before I draw anything, dotted or solid?
Solid.
Solid, because I had the equal to sign, good. Okay, so let's go back for our second one and do the same thing. When x is equal to 0, the 3x is equal to 0, so I just have 2y equals minus 6. Dividing by 2, I get y equals negative 3. And when y is equal to 0, I get 3x is equal to negative 6. Divide by 3, and I get negative 2. I know I'm doing that fast, but I'm hoping finding intercepts of straight lines is pretty straightforward, yes? Maybe? Straightforward. I see my own joke there. Thanks, Ashton. I didn't mean that at all. All right, so let's plot that. Y equals minus 3, 1, 2, 3, and x equals negative 2. So they should be two parallel lines like that. Oh, that's a little bit wobbly, but they should be parallel. Whereabouts am I going to shade? Yep, let's test though, just because we should. Let's test the origin. Let's test 0, 0 into the original inequality. So that would be the absolute value of 3 times 0, which is 0, plus 2 times 0, which is 0. Is that less than or equal to 6? Yes, because 0 is less than 6. So that's true, which means between those lines is the solution to that inequality. All right, one more. And I've got to fix my sign again. So that should be a less than or equal to 25. So sketch the region of x squared plus y squared equals 25. But, I mean, that's okay. But I also have to put on there that x must be less than 3 and y must be greater than minus 4. One bit at a time. Start with the circle. X squared plus y squared equals 25 would be a circle on the origin with a radius of 5. Okay, is it a dotted or a solid line? Solid, great. Oh, that wasn't a very good curve. All right. Now, if it says x squared plus y squared is less than 25, I could do a little test of my origin, and if I sub that into my inequality, it would be 0 is less than or equal to 25, which is true. Okay, so hopefully you know that means I want to shade on the inside of that circle, but before I do, I want to consider those other criteria that I've been given there. First of all, it says that x must be less than 3, which means 1, 2, 3 is there. X equals 3 would be a straight line going through the 3, but it will be dotted because it does not have an equal to sign on it. Y is greater than 4 is, or minus 4, sorry, thank you, is down here. And again, it does not have an equal to sign on it, so it would be a dotted line going that way. Now, the question in everybody's mind should be, do those points actually line up? Are they actually connecting there in the corner? So we should do a little, if you're not sure, we should do a little test. Let's see what happens if we sub in when y is equal to minus 4 into our circle equation. So that would be x squared plus y is minus 4, so minus 4 squared. I'm just doing it in the equals to. I'm not worried about the inequality part. I just want to see if they intersect on that circle. So that's equal to 25. So x squared plus 16 equals 25. If I subtract the 16 across, I get x squared is equal to 9. And when I square root, what happens? Plus or minus 3. So that does mean that this little point here, they would both be right there on the edge of that circle at 3 minus 4. Okay, so do match there nicely. I still need to shade. Greater than 4 is going to be above. Less than 3 is going to be that way. And we know we want the inside of the circle, so we know it's going to be, hopefully we know it's going to be, all this part in here. There's one more thing that I haven't done on this question. That's right, the points of intersection. Are they going to be open circles? Are they going to be closed ones? Yeah, because it says that it has to be less than 3, this value here is on the 3. It has to be an open circle, okay? This one here is also on the 3, open circles. And this one, it had to be greater than minus 4, so they are all open circles. So open circle here, here, and here for those points of intersection. Lots of things to